Hi everyone, this is Larry Feldman with a lesson on 45, 45, 90 triangles. 45, 45, 90 triangles play an important role in geometry and trigonometry. In another lesson I talked about 30, 60, 90 triangles, which are also critical in those topics or in those subjects. However, 45, 45, 90 triangles are much easier to analyze. So let's get started by drawing a 45, 45, 90. And what we will do is label the angles at the top and lower right as 45, 45. And since the sum of the angles in any triangle must be 180 degrees, that requires this angle in the lower left to be 90. And this triangle is isosceles because it has two angles that are congruent. And if two angles are congruent, the opposite sides are congruent. So we can denote congruency using these red tick marks. And now let's take it another step and label this leg as x and this leg as x. That means that we can label the hypotenuse using any variable we wish, and I will use the letter C. Now from here, it's a straightforward matter of applying the Pythagorean theorem. So we can say x squared plus x squared equals c squared. X squared plus x squared is 2x squared. And then what I'd like to do is reverse these terms, and I want to put the c squared on the left and the 2x squared on the right. And at this stage we take the square root of both sides. And on the left, the square root of c squared becomes c. And on the right, we are left with root 2 times root x squared, which simplifies to root 2 times x, since the square root of x squared is x. And finally, rearranging the terms, we have c equals x root 2. So we can come back to our diagram, erase this letter c, and replace it with x root 2. Because now we know that if the leg of a 45, 45, 90 triangle is x, the other leg is also x, and therefore the hypotenuse is the square root of 2 times the length of the leg. Now the square root of 2 is roughly 1.4. So that means that the hypotenuse is roughly 1.4 times the length of either leg. So just to jot down a few simple examples, let me draw a 45, 45, 90 here, and I will do another one here. And let's put the right angle in the lower left of both of them. And just as a couple of examples, let's say that the length of the leg is 1. That means the length of this leg is 1. So in other words, x equals 1 in this case. The hypotenuse is 1 times root 2, since it's x root 2. Well, 1 times root 2, we can just simply write root 2. And I just want to clarify that these angles are 45 degrees, and that is apparent by denoting them as congruent. If I go to another example and I have a hypotenuse of 3 root 2, this leg is 3 and this leg must be 3. Because again, the hypotenuse is root 2 times the length of either leg. And as I mentioned, this analysis is fairly straightforward, and every 45, 45, 90 triangle that could possibly be created must conform to this model that we've derived. And in another lesson, I will do some more examples of solving triangles using this property, and also the property of 30, 60, 90 triangles. In the meantime, please visit my website at www.lfeldman.com, where you will find links to my mobile applications. My mobile apps cover math subjects from algebra all the way through calculus, and they contain hundreds of examples, tutorials, and solvers.